So, hello everyone. My name is Tomek Kopczuk. I'm the CTO of SwingDev. And today we'll talk about making API calls the right and the wrong way. So, why should you even listen to me? That's a good question to ask before any presentation. I have over a decade of professional experience and coded, architected, even audited dozens of systems for startups, Fortune 500 companies, Silicon Valley venture capitals. And as a CTO, I've been blessed with a very rare honor of seeing many MVPs of different startups in their very early days, before they became famous. And some very interesting patterns emerge. And the only thought I have is our internet is too damn fast for our own good as developers. And let me show you what I mean. This is a modern web application, as we call them, seen through the eyes of its developer. Bugs, GIFs, pretty cool. Now, this is the same web application seen through the eyes of a user. Over LTE and using a real server. Not that far away, same region as the front end, but as you can see, far enough to cause problems. Fetch a list of tags, funny images, and image source to be covered from legal standpoint. Simple, nothing fancy. And the user is just crying inside. We don't test our apps in the same environments our users are using them in. I'm not going to say anything that will come as a surprise to you guys, but it's important to not forget that according to statistics, over half of internet users are on mobile LTE, and we, developers, are not. Mobile connection is always slower, has bigger latency, and, what's important, sometimes fails. And we can't really do anything about it. Or can we? So this fine evening, let me give you 4 things you should be doing in order to make your frontends much more pleasant and welcoming for your users. All of them connected with how we make network requests. Firstly, failures. And I don't mean your usual validation errors and like this. Let's talk about small failures that happen on the wire. This is frontend that makes quite a few requests. And those are your just transient 502s, 503s, lost LTE connections. Actually, if you look at the service level agreement of your load balancer, you'll see that, for instance, Google's load balancer responds with 502 in 1 in 200 requests. It's certified for 99.5% SLA, regardless of whether your application is up or down. And some of these errors will be on your side, some of them will be on your user's side, but you can actually fix it by automatically retrying the failed requests. And this is how we do it. If a request fails, check the error and retry if it's likely to resolve itself. We call it transient failures, with exponential backoff, just to make sure you don't kill your backend while you're at it. If it fails a couple of times, only then notify the user. And on the workshops today, you'll get to implement this very measure. This is how it looks in code. We start from this very simple request making method. And we wrap it with a library that can retry automatically with dynamic delay, depending on the outcome of your promise. In this case, I used async retry, but there's actually plenty of them out there. If the response didn't come, or if it came and was of a 500 variety, we retry. And let's see how it compares to the original version. On the right, same frontend, just with automatic retry implemented. A user won't even know that he or we had any issues. One of the servers is down, doesn't matter. It's cool, right? And one of the most famous examples of this was Google Picasa app on Android. They had a couple of huge downtimes, like queues were piling up, nothing was getting done on the backend side, none of the users even realized that this was happening. That's the definition of an amazing frontend, really. Get things done and alert me as a user only if I can do something that I can actually control. Everything else, just fix it for me, if possible. I don't want to deal with this kind of things as a user. Also, you know, every one of us has a story of an own best or worst, depending on how you look at it, professional fuck up. And this measure is actually the only thing that prevented my biggest professional fuck up from being noticed by any users. But that's a story for a separate talk, really. And while we're on the subject of making too many requests, that's one of the most common problems we see with all the frontends. Making requests carry a significant overhead. And let me show you a small demo. Same application, but with statistics that explain why it's so goddamn slow. Same slow LTE connection. Look at the requests counter at the bottom. Look at the number of requests. It's right here. Got bored yet? That's the point. Feel your user's pain. And this application fetches each resource one by one by ID. Some of them are redundant. As we've seen on the first demo, this application flies on developers' environment with local server and everything. But this is how it works on someone's subway ride home. And I didn't even simulate a very bad connection. This is just a mediocre LTE connection that's actually very common in the US. So, first thing we can do is we can eliminate redundant requests. So basically making requests to the same resource, just because we want them in different components, let's say. Same simple request making function. Let's add a decorator to it. Now, decorators, by the way, are, in my opinion, one of the most useful features of ES7. It allows you to add some generic functionality to a specific function, and it fits this use case perfectly. So, small interlude. What are decorators? This decorator will log a message on each execution of a decorated function. And how it works is you take the original function. It's probably better this way because you can actually see something. And you change it into a different function that does something and calls your original function. So there's an example right there. And if you call it in, let's say, Chrome DevTools, this is what would happen. So basically, the decorator is called first, and it can call, in turn, your original function. Back to our example. This decorator could be defined as such. You copy your original function that was there, create a cache for your ongoing promises, and override the function with a function that will check if the cache is there. If the request is already cached, just return it. If not, cache the original promise with handlers for both success and failure, just delete it at the very end. Because what we're aiming for is to make sure that we don't change the logic by adding this, this decorator. And return the cache at the end if arguments match. If not, original logic stands. So let's see if this helps or not. You should care about not making any redundant requests because it's not only a waste of bandwidth, which, mind you, costs your users money, especially in the US. It's also putting unnecessary strain on your backend. It's, I admit, small with caching, but still, it's quite sloppy in general. It's almost finished. It's actually better by 10 seconds, which is quite a lot, and 30 requests. Now, usually at this point, someone just says HTTP2. It was supposed to solve exactly this problem. So let's see how it compares. Again, same application, HTTP2. You can see straight away that it behaves in a completely different manner. Request starts faster and don't wait for the other ones. They just queue up quickly and go all at the same time. There's much more concurrency here, and it is way better by 20 seconds. But I made you suffer through all those demos for a reason. It's still frustrating, and it's still not good enough. It's not good enough to just reduce the number of requests by some percent. You have to rethink how you're fetching things. Just take it down to a few requests, the ones that really matter. And let's see what's the cause here. Designing REST APIs sometimes results in the frontend making way too many requests. It always starts with one, then it's two, then just like magic, tons of them appear, not by design, by accident. And in our development environments, it's easy to not even realize this problem before it's too late, and the user is waiting. Nah, we solve it by gathering all the requests and combine them into one batch request. And look at the difference. It's going to be the same slow connection. On the left, the HTTP2 optimized version. On the right, the batched version. Done. And that's on a slow mobile connection with a huge latency. On the workshops, you'll get to implement this as well, but with a small twist. Just to be able to use this in a big application, like a legacy application that already makes requests the wrong way. The third one is a bit of my pet peeve. You have to communicate what's happening with the user. Do you know what happens if someone clicks a button and nothing happens for just half a second? Yes, you do. They just hit it again. And this is usually what happens. And it's our fault, you know. Like, we make things respond slowly, and the users are just used to having to click things twice. So let's prevent it. Better, right? Just communicate that something is happening. Users should not be feeling anxious and uncertain about what's going on. And according to a 2004 study on user behavior done at the University of Nebraska, not only does using loading indicators reduce frustration, it also makes people perceive the loading times as shorter. And there's a lot of studies out there into how the progress bars should behave to make us feel better about loading times. I believe Safari was the first browser to completely decouple the progress bar from actual progress. And we compared the result, the real version, the completely fake version. I think it was 10 years ago. And just give me the fake one all the time, because it just feels better. And again, on a very bad LTE connection, this is what we started with on the left side, and the right side is after the application gets the SwingDev treatment. Done. And that's how the web should look. But don't believe me. Play with the demo yourself on your own phone at https microconf2-demo.swingdev.io. Experience both the problem and the solution. This is how the demo looks like. And you can just enable and disable all the measures. And I encourage you to do that, because all of the measures I was talking about take no more than 20 lines of code. And they are completely generic, and you can use them for all the requests. And if you do, if everyone did it, the web would be a better place. On our GitHub, you'll find the React code for this demo and for the API. It's a MIT license, so feel free to use any of the decorators there. I actually encourage you to do so. I also encourage you to take a look at our Frontend Developer's Guide to SwingDev, where we have this and a couple of more things for your users' ultimate satisfaction. For example, how to prepare images to limit bandwidth, how to architect error handling, set up your tests, and more. And this is an electronic version of the book that actually every front-end developer receives when they join our family. We also love sharing and have some great open source and some great articles that I can, I guess not surprisingly, recommend on Medium and GitHub. You can also follow me on GitHub or Twitter, but don't do that because I try not to use social media, as I tend to have kind of strong opinions about things. Might be taken out of context. And that's all, folks. So thank you for listening. And those of you who signed up, workshop will start after the break.
I have one question for you, Tomek, and it is: how do native mobile applications do requests? Not web, the native ones.
It's a weird question, but actually a pretty interesting question. So it's pretty interesting because we started, and actually I started as a mobile developer. And I would say up to 6 years ago, every mobile application was doing all of the things are mentioned, especially the first one, especially automatic retry, because every native developer knew that those applications will be used on a very bad connection, you know, with GPRS and 3G back then. And they were architected in a way that would not make the user notice that this connection is very spotty and very bad. And I think we kind of forgotten about this because about 6 years ago, it all started changing. And even native applications nowadays don't do that. If you look at even Instagram, it's pretty much impossible to use on a subway in New York, which is like connections in the States especially are completely different from the LTE we know back home here, because our LTE is amazing. In the US, it's spotty as hell. And people no longer think about it, and they should.